Hello everyone and welcome back. Today we'll be solving another interesting question called length of longest palindrome. And here is the question. You are given a linked list consisting of n nodes. Your task is to find the length of the longest palindrome in the linked list. Note, expected space complexity is big of 1. So basically the question is asking us to solve without taking any extra space, or you can say in the constant space. And here is the input format. So the first line of the input contains an integer n denoting the length of the linked list. The second line contains an n-spaced positive integer representing the node of the list. So so basically we just need to complete a help method. That's it. You don't have to read the write or something. You will be given with a singly linked list node, guys. You just have to print out. So I'm gonna skip the part where I will be creating, reading, all that thing is not that. So let's straightforwardly jump into the question. I'll take the sample input and I'll just put it down here and we'll discuss about what the question is asking. So for example, if there's the question, all the question is asking is return what is the longest length. So we have written the length first of all, guys. What is the longest length that you can have of a palindrome in this particular linked list. Okay, so we start so let's assume if I start from here, I have all these elements and all of these elements are same. So there's like 1 2 3 4 and 4 plus 4 8 plus 1 9. So I think probably answer is going to be 9. Yeah, so this question is again pretty much straightforward and there's not of a complex algorithm, but it would have been way much simpler if this question was like an array or something. We could have done it with the help of a DP, which would have an n square, or else with some algorithm, which was going to give you like a big of n time complexity. But right now here the challenge is you need to do it in constant space. So one way of doing the same is probably you would have reversed this entire thing and called maybe L and L hyphen, and then you could have started from one place, like both the starting points, and you could have checked if this and this is matching, this is matching, this is this matching, and you could have written whatever the answer is. Okay, but to do that you need an extra space of n, which is not allowed right now. So the idea of reversing it and storing and iterating through is completely out of the context right now. But yes, that's one potential way of doing it, but that's not accepted. So let's go and figure out other ways how we can solve this. uh, yeah, you make it inspire your algorithm from considering or thinking how you have solved this in arrays, but I would say that don't go in deep, just stick with the concept of how you can do it. Okay, so just take a thinking pause and come back and we'll solve how we can do this. Okay. Okay, guys, so let's get back to the question. So, since this question is more inclined or more concerned about the space, and the question isn't talking about the time, so let's take a lineage on the time and let's say that how can we do it without taking extra space. So, the way my initial intuition is, okay, I am not allowed to have this to construct a reverse, but can I do something and can I go and check how many of what if I am trying to construct this, mm, a reverse. Like you do know how we reverse an linked list, right? We basically just take this arrow, we make this arrow to the previous one. We have like a previous and next pointer, we point our current point to the previous one, and you just play around with the connections, correct? So how about I still go ahead and try to reverse my actual linked list, and in that time I go and check how many common sequences that I have so far, the longest common sequence that we can have, and then probably with that count. So, for example, if I'm starting from here and the first half of the array is reversed, and here I'm going to be the next half. So, what if I check with this and this half and check how many of them have a common sequence? So, when I say common sequence, that basically means that how many of them is going to have like the next and next is going to be same with the counter gets increased and increased and increased, something like that basically. So in that aspect, like here you have 16, you have 16 1 and then 11 and 9 and basically 4. Okay, 4. And then I will say that okay, I have 4 elements seen, but we know that that's only one half. So we're going to multiply by 2 and I'm going to see that I have 8 elements in total. But since there is also 1 in the middle, I'm going to just add it 1. So every time I can either include this or exclude this, and I can go ahead and check it out quite simply. I can check with my current and to the next element, or I can check with the previous to the next element. So this is something like I can do, and I can check and count it. So basically, yes, there are going to be extra iterations, extra recursive calls, but at the same time, this we are not allowed to store, but we can take a toll on the time. So let's go ahead and do that. Every time I'm reversing, I'm going to check with my previous to next and current to next guys, and check how many of them have this common count, and I'll be just greedy, I'll be just take the maximum length. That's it. That's it pretty much. So here's my algorithm. While reversing, while reversing, I'll go and check the common count. So the common elements count for my previous to next, and same thing I'm going to check for the common thing from my curve to next, and I'll just save that number in a result called global result, and just written it back. That's it. A typical reverse with a twist in it. So let's go and try to implement. As I most of the time feel that the linked list questions are more implementation heavy than the algorithm heavy. So ideally, yes, there are a few questions which are really, really hard to come up with an algorithm, and definitely this question is also a part of that. But at the same time, coming to what kind of a language you choose, the implementation changes drastically. So let's see how I'm going to do it here. That's all, guys. That's pretty much simple and precise to the code. Let me just quickly check if there are any syntactical mistakes. There aren't any. So let me just explain what the code I have written. As I said, I'm going to write a typical reverse code, but at the same time, a bit minor twist of checking what is the maximum number of common elements I have. So here I am placing my next node and then putting my current equals to previous, having that connection swap, and then I'm just checking how much I have, like from previous to current, previous to next, and current to next. And here I'm taking just multiply by 2, as I explained you. Like from here, when I'm taking, that basically means that I only have the first half. So this is going to be multiplied with the next half, so the 2 into that count plus 1 for previous, because I'm going to include the center one, and in case of current, this is already included this now, so that's not required. So once I'm doing this, I'm just continuing with my previous reversing algorithm and returning the result. Here in the helper method, I'm just checking the given two linked list. If the data is same, I increment the counter, else I break it and I return back the count. So it could be 0, it could be any number and multiply by 2, and that's how it's going to be working. So what I am just doing here is, if you have like L1, L2, L3 and L4, so on and so forth. First of all, I am constructing a reverse thing, and I'm calling this as the center of my palindrome. I'm checking, I'm trying to increase the area and check what is the maximum length that you can found. So then in the next step, probably I'm making this as the center of my palindrome and constructing this edge, and I'm checking how long the palindrome is. Yes, that's all, guys. Let's try submit our code and see. Accepted. A quick summary to the question. Here we are not going for a very fancy algorithm, but rather we are just sticking to the basics. We are not trying to use any extra space, but we are taking a toll on the time complexity. At every step, we are making that particular node as center and trying to expand through its left and right and check how many nodes are there, which are identically the same. And at every step we are just taking the maximum count in the saving the result, and we are just reversing the rest of the array. That's all it works. That's about the algorithm, and here is the code. Thank you so much.